The figure shows a uniform rectangular lamina OQRS when OQ is 4A, OQ is 4A, so this side is 4A, and QR is A, QR is A. The sector OPS of radius A and center O is removed from the lamina, given that the center of gravity G of the sector OPS is at A. Sector OPS is at a distance 175/3 pi from both OQ and OS. Find the distances of the center of gravity of the remaining lamina PQRS from OS and OQ. Solution. First thing, let the weight per unit area to be equal to W, and let G, the center of gravity, have coordinate X bar and Y bar. So now we are going to draw a table of the various sectors of our rectangular lamina, and then we're going to give their areas, and we're also going to give their weights. We're going to give the sector, we're going to give their weights, and then the distances from OS and OQ. So let's do that. We're going to have here the sections, the weight of that section, and the distance of the center of gravity G from first of all take from OS and then from OQ. We're going to make the table. We'll make this a table of this form. The first sector we are going to consider is the OPS sector first. So I'm going to take the first section, OPS. I'll roll a line here. I'm going to take the second sector, OQRS, which is the rectangle. Now PQRS, which is the remainder. Now the geometry is that, I have OQRS, the rectangle. So it means that OQRS is the rectangle, and it is divided into OPS and PQRS. If you look well, notice that this is a composite lamina, because it's made up of two different bodies. Now, what to calculate the area of this? So the area of the sector OPS is going to be pi A squared over 4. Because the area of the sector is pi on 4 r squared, radius squared. The radius is A squared times omega A times W, the weight per unit area. Now the distance from the center of gravity of this section OPS to OS is the same as the distance from there to OP. That distance is equal to 4a over 3 pi, and is the same 4a over 3 pi. Now for OQRS, which is a rectangle, the area is given by length times width. So we have 4a times a is 4a squared. We have 4a squared w. The distance from the center of gravity of the rectangular lamina to OS will be 2a. And the distance from there to O pure will be a over 2. Now we have that PQRS. PQRS is from here we have that PQRS is OQRS minus OPS. So it means that the width of PQRS will be this minus this. In other words, we are going to have this minus this. OQRS. This minus this. So we have OQRS, which is 4a squared minus 5a squared on 4 times w. It's going to be at a distance x bar and y bar from OS and OQ respectively. Now the principle of moment is applicable. To apply the principle of moment, we are going to have that 4a squared minus 5a squared on 4 times w times x bar is equal to 4a squared w times 2a plus 5a squared over 4w times 4a over 3 5. Our interest is to find x bar, and if we do that well, we'll have x bar as 92a over 48 minus 3 5. Now we're going to take moments. This is for principle of moments. Here we're taking moments about OS. Taking moments about OS. So now I'm going to take moments about OQ. Taking about OQ, I'll have this OQ. Taking moments about OQ. Now I'm going to have 4a squared minus 5a squared on 4. 4a squared minus 5a squared on 4 w times now y bar will be equal to y bar. This principle of moment, it states the moment of a force is the magnitude of the force and the perpendicular distance from the axis. So that's why we have the magnitude of the force times the distance. The force is the width and the distance, perpendicular distance from the axis. So for example, this is our axis here now. So we're taking a moment about OQ. So OQ is our axis, and so the distance from OQ is the y distance. That's why we are going to have the y coordinate of the center of gravity. Will be equal to 4a squared w times a on 2. 4a squared w times a on 2 plus 5a squared on 4. 5a squared on 4 w times 5a on 3, 5a on 4a over 3, 5. If we do that well, we'll have y bar as 20a over 48 minus 3, 5. So this is 8 for the x bar and y bar, the x and y coordinates of the center of gravity. In other words, that is it for the distance That is it for the distance from both OQ and OS. The distance from OQ is this, is the y coordinate of the center of gravity, and the distance from OS is the x coordinate of the center of gravity. Thank you for watching. Please subscribe and see you in the next video.